For example 2, it says, what conjecture can be made about the number of dots in the nth term of this geometric pattern? So, we're going to establish the term. It says the nth term. So, it wants to have like some rule for all the terms, right? Term 1, n equals 1, term 2, n equals 2, term 3, n equals 3, term 4, n equals 4. So, whatever term you're on, that's what n equals. So anytime you want to establish a rule based on which term in a sequence you're talking about, you want to establish that that's the variable we're going to use. So when I use the letter n, it represents what term number I'm on. So if I'm on term 20, that'd be the 20th picture like this in the sequence way over there. And what we're counting on each one of these terms is the number of dots in the picture. So if we take a look at the number of dots in the picture, and I want to relate, if you look at this picture here, I'm looking at it, I've got columns and rows, right? So this is the number of rows, and this is the number of columns. Right? So columns are like this, rows are like that. So this has 1 row and 2 columns, right? So in the first term, we have 1 row, 2 columns. In the second term, how many rows do we have? 2 rows. We have how many columns? 3. The third one, how many rows do we have? 3 rows. How many columns? 4 columns. The fourth term, we have how many rows? 4 rows. And how many columns? 5 columns. And notice, 1 times 2 makes 2, and 2 times 3 makes 6, and 3 times 4 makes 12, and 4 times 5 makes 20. That's where those numbers are coming from, those 2, 6, 12, and 20. It's by the rows and columns. We can count the dots, 1, 2, 1, 2, 3, 4, 5, 6, and so on. But again, the dots are being created by how many rows and how many columns there are, right? Now, if we consider then, how do the number of rows and columns relate to the term we're on? Board is not going to be my friend today. Oh, well, I guess I'll get a highlighter today. Maybe oh, it's doing stuff now. There we go. Seriously. Highlighter. All right. So, I want to look at the term number we're on and relate it to, first of all, the rows. Term 1, we have 1 row. Term 2, we have 2 rows. Term 3, we have 3 rows. Term 4, we have 4 rows. So the relationship between the number of rows in the row and the term we're on is they're the same, right? So if I get the term n over here, dot, 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 term n. That's weird. I'm going to have n rows, right? Okay. And then if I'm focusing on the number of columns, again, relating the term we're on to the number of columns. In term 1, we have 2 columns. In term 2, we have 3 columns. In term 3, we have 4 columns. In term 4, we have 5 columns. How do the term number and the number of columns relate to one another? How is this number related to that number for each thing? The columns is 1 more than the term we're on, right? So again, we're over here at term n, and we have a +1 to the number term we're on, right, for the number of columns. So I would expect there to be n plus 1 columns. Right? And we're getting the number of dots by doing what? What do we do to these two numbers to get the number of dots?
Multiply.
We multiply them, right? So if I got n rows times n plus 1 columns, and n plus 1 being a binomial, I have to put in parentheses, treat it as one object. I'm going to multiply n times n plus 1, which would, by the distributive property, give me a rule that says n squared plus n dots would be what we get for the nth term. If we wanted to test it out, we can very easily find out what row 5 should be, right? row 5 should have 5 rows and 6 columns. 5 times 6 should be 30 dots, right? If we try 5 in here, what's 5 squared? 5 squared is? 5 times 5? 25. And then plus 5 makes?
30.
The right number, right? So again, that rule right there is working, so that's what we're looking for. So when it says, find a rule, or whatever, that's what they're looking for, some algebraic expression to represent what the end term. So now, if I need to know the 40th one of these pictures, how many dots would there be, right? Well, that'd be 40 squared plus 40. 40 squared is 1,600, so 1,640 dots would be in the 40th row. So again, use a little bit of algebra mixed in with this whole idea of inductive reasoning, and we can come up with a way to predict any number down the road, no matter how big it gets, as opposed to having to keep drawing this picture. Can you imagine all the way to the 40th row? Ginormous thing we'd have to draw to count the 1,640 dots. So again, that's all we're doing here. So when you're doing a problem like this, I recommend that you find a way to get these numbers through a little bit of geometry. So that's just basically area. It's 2 columns by 1 row, 2. 2 rows by 3 columns, 6. So look for a geometry pattern. So instead of just looking at these numbers alone, then you can establish something simpler that can do the same thing.